So today is Introduction to Evolution. If you have not read the section in the textbook, please go and do so and then come back and watch this video because I am not going over what's in the textbook. I am just really pointing out the things that you have to know. You also need to know those things in the textbook. And so the vocabulary that's in that section, bold words, you need to know all of that and be able to have a conversation with me about it the next time we see each other. What basically I really need to highlight for you is the difference between Darwin and Lamarck is the first thing we're going to talk about. Darwin, of course, we call him the father of natural selection, evolution. He actually was the one that made the theory make sense. Theory of evolution makes sense. And so really that body of evidence that he collected made it where evolution was a viable theory and a correct one, actually. But the difference between Darwin and Lamarck, who was before Darwin talking about evolution, was that Lamarck used an idea that if you needed an adaptation, it would arise. If you did not need it, it would go away, as if the actual need was the reason that evolution was happening. So we go to that pictures of the giraffe, that showed the stretching neck and, he needed to reach the tree. And so he stretched and stretched and then his neck got longer. And of course we know that you can change during your lifetime. You can have a longer limb. If you're stretching a lot, you can stretch the ligaments, it can become longer, but it's not going to be passed on to your offspring. And so that would mean that every giraffe born would still have a short neck and would have to stretch their neck during their lifetime, is what we know. But Lamarck's theory, or not really theory, hypothesis, was that the giraffe could stretch its neck and get really long and reach the acacia trees, and then his offspring would have a long neck. And we just know that's not true. And also, he had the hypothesis that if you didn't need something or you didn't use it, it simply went away, and then you no longer had that particular trait, which we know is not true. Now, unfortunately, the way multiple choice questions are written, students will fall for Lamarckian reasons all the time. And I will write on your paper, this is Lamarck. Like, you are answering the question as if you are Lamarck. And we all know that that's not the correct hypothesis. In fact, what Darwin said that was completely different was that if a giraffe, and he didn't really talk about the giraffe, but we'll use that example. If a giraffe was able to reach the acacia trees, it would survive better, therefore passing its good genes, its long neck genes, on to the next generation. Those that could not reach the tree would then not have as many of their offspring passed on because they wouldn't be as successful in life. So if you don't eat as much, of course you can't reproduce as much because you don't live as long. Therefore, your genes don't get passed on. So we are talking about evolution is talking about the gene pool of a whole population. You cannot get into the thinking, the mindset that evolution is talking about an individual. It is not. It's not talking about an individual at all. Individuals make up a population, but evolution is only when the population itself, the gene pool in there, has changed. And so that's what we're looking at. So one giraffe stretching its neck and making it a little longer is not going to change the actual gene pool of the population at all. So that's not evolution. That's not changing the gene pool. So that's one thing you have to get set. So once again, to reiterate, what you have to really get into your mind is that evolution is the population change. And it is not about what is needed or what is not needed. It is just about random chance. If a gene makes an organism more fit, then it will survive and produce more offspring, and therefore that gene will actually be built up in the population over time. That's it. It's not a complex theory. Now, the reason for the change, there's a lot of reasons for the changes, and that's what we'll get into in the following weeks. But right now, you just need to know that bit. Now, also, I want to also let you know that evolution happens based on the phenotype of an individual. So the phenotype is like the outward appearance, the expression of a gene. What does it look like? How fast can it move? How long is the neck? All of those things are the phenotype. The phenotype can also be inside of your body, like something you can't see, like maybe sickle cell disease. Maybe we've talked about that. Or maybe something like how many chambers your heart has, what type of blood you have, A, B, ABO. Those are all phenotypes. And so even though you can't see them, evolution acts on, or natural, when we talk about natural selection acts on the phenotype, the expression of the gene. Now, by default, then, if it acts on that, it actually changes the gene pool. But your environment is not acting on the genes themselves. And that's an important distinction to make. It's going to act on the phenotype first, and then down the line, domino effect, the genes will be altered in the gene pool. So if you could just count up genes in the gene pool, and you count them up 1 year, and then 100 years later, you count the genes again. If they're different, then evolution has occurred in that population, okay? It doesn't matter which individuals are there. Of course, it'll probably be different individuals, because 100 years, very few animals live that long, or plants, okay? So make sure that you understand the base concepts of evolution. Like, if I give you an example, and all of your questions in AP Bio are going to be an example. They are not going to be, what does evolution act upon? And you have to write phenotype. That's not, no, AP Biology, all your questions are going to be based on scenarios, and you have to try to figure out what is going on and what nature is acting upon. Okay. So make sure you practice trying to figure out evolution, do the work, do the worksheets, make sure that you're trying to actually understand what evolution is and how it's happening. All right, I'll see you soon. Hope you have a good day.